Hi everyone, this is Anitha, Department of AIML and IoT, working as Assistant Professor. Today I am going to discuss about agent environment and different types of architecture in agents. Now coming to the contents in our lecture are agent and its environment, example of an agent. Here we discuss about the vacuum cleaner, the mini world, and next the discussion about the piece, performance measure, environment, actuators and sensors, and next basic agent architecture and different types of agent architectures. Now coming to the point of agent and its environment. Here an agent is anything that can be viewed as perceives its environment through sensors, acting upon that environment through actuators, and then assumption. Every agent can perceives its own actions. Here it is the agent, and here the different types of sensors are there, and then the perception will be going on by using these different types of sensors, and then the actions or set of actions will be defined by the agent, and then these actions will be performed by running to the actuators to the environment. Next, in agent and its environment, the perception. The agent can perceptual input at any given instant. At that current moment, what is the status of the environment? This is called as perception. And then percept sequence, complete history of everything the agent has observed or the agent has perceived. An agent's choice of action at any given instant can be depend on the entire perspect sequence of observations up to date. Next, the agent's behavior is described by the agent function, which maps from percept histories to actions. Here, the agent's behavior is described by the agent function. Here, in this concept, we are using f. F is the function of P star to A. Here P star means certain number of perceptions of agent A. This agent function will be implemented by an agent program which runs on physical architecture to produce F. Means the agent can be defined as the architecture and the program. The combination of the architecture and program is called as the agent. Next, this is the structure of an agent program. Here we have certain number of sensors. By these sensors, the perception will be going on to the agent program, and then it returns some sort of action by the actuators. In this agent program, it can take the current percept from the input, because nothing more is available from this environment in case of agent program. Whereas in case of agent function, same like the different components, but here the only difference is the full perception history is supplied to the agent function. Here the agent program collects only the state of the current environment, whereas the agent function can collect the percept history, whatever going on previously. Next, this is the main example of vacuum cleaner, autonomous vacuum cleaner. Here the number of components to accomplish the task. To clean the room is the main task here. What are the 6 components here? Different states. What is the initial state? What are different sort of actions? Transition model, goal test and path cost. First, we have to discuss about state. What is the state here? The state of an agent means here the vacuum cleaner is determined by both the agent location and the dirt locations. For example, the agent has two locations, means room A and room B. In room A, the condition will be dirt, also clean. Then the number of states here are 2 into 2 to the power of 2 equal to 8 types of different states are there. A larger environment with n number of locations has here n into 2 power n states. It can be defined by using these elements. Location of A, comma, dirty of A, comma, dirty of B. Here location location A is dirty and B also dirty. And second state, location A room is clean and B room is dirty. Whereas we consider location A is dirty and B is clean. Likewise, location B, A is dirty and B also dirty. Next, in location B, A is clean and B is dirt. Likewise, we have 8 types of situations or states are there. Next, what is initial state? Any state can be designed as the initial state. Means any type of state, whatever the agent can start to do its task will be treated as initial state. Next, what are the number of certain tasks here are? Each state has just 3 actions. First one is move to the left and then move to the right or clean the dirt or suck the machine. This is the transition model. The actions have their expected effects except that moving left in the leftmost square. Here, for example, the room is dirt. Means here, look, A is the room which was dirty. B is the room, also it has also dirt. The robo is here in room A. It has to clean this dirt and then move to the left side. Move to the right side. It can't move left side because left there is no room. So, conditionally it has to move right side to clean room B. Next, goal test. What is the component here? Goal test. This checks whether all the squares are clean or not. This is the goal. When the rooms are clean, then only it can achieve the goal. Next, path cost. Each step costs 1. So, the path cost is the number of steps in the path. Next, the function will be treated like this. 2 locations are there, A and B. Perception is here, location and contents. For example, location is A here. It is dirty. And then actions are left move, right move, suck, no operation. If suppose the rooms are cleaned, then the operation will be no operation. It can state. Next, percept sequence. These types of states are sequentially ordered like this. And certain actions are written like this. One simple function here is if the current square is dirty, then suck. Otherwise, move to the other square. So, here the worked function is reflex vacuum agent. The name of the function here is reflex vacuum agent. Location, comma, status. It returns an action. Here, the agent can work based upon some if-else conditions. If status is dirty, then return suck. Else, if location equal to A, then return right side. Already we discussed in that diagram. If A is dirty, after cleaning, it can move to the right side because B is right to the A room. Else, if the location equal to B, then return left. If the robo is in room B, after cleaning the room B, it can move to the left side. These are the different states and certain tasks or actions. Next, peace. When the designing of the agent will be accomplished, the first and foremost task here we have to consider are four components. First one is performance measure, and second one is environment, and third one is actuators, and fourth one is sensors. Next, for example, if we consider the vacuum cleaner, what are the performance measures here we consider is cleanliness of the floor. If the rooms A and B are cleaned, then the agent has to reach its goal. It will be considered as performance measure. Next, what are the different environments here? A room with dirt in random locations. The environment here we consider is, in our example, vacuum cleaner, room A and room B. Next, actuators, wheels, vacuum suctions and brushes are treated as actuators. Then what are the sensors here? Bump sensors, dirt detections, cliff sensors. These are sensed the dirt. Next, consider an automated taxi driver. Performance measure here are safe, fast, legal values, comfortable trip and maximize the profits. These are all considered as performance measures. Then what is the environment here? In case of automated taxi driver, roads, other traffics, pedestrians, customers are taken as environment. And then what are the actuators here? Steering wheel, accelerator, brake, signal and horn are the actuators, because certain types of actions are performed by the actuators according to the sensors. Next, sensors. Cameras, sonar, speedometer, GPS, odometer, engine sensors, and also the keyboard will be treated as sensors. Next, in case of medical diagnostics system, the performance measure consider as a healthy patient, minimize the costs, lawsuits. Here the environment is patient, hospital and staff. Here what are the actuators? Screen displays, questions, tests, diagnostics, values, treatments and referrals. Here the sensors are keyboard, entry of symptoms of a patient or a disease, findings of different types of diagnostic values, patient's answers are taken as input to the sensors. Next, consider the satellite image analysis. Performance measure here is correct image categorization by using some of the computer vision techniques. Then environment, downlink from orbiting the satellite. This is the environment. And actuators, display categorization of scene and horn, sensors, color pixels of arrays. Next, here we discuss about the basic agent architecture. Agentic AI architecture is a software system where an autonomous or semi-autonomous agent pursues a goal by set of actions, set of steps. Here first one is planning of actions, invoking tools, observing outcomes, updating what it knows, and last one is repeating this loop until the agent has to reach the objective and any types of safeties or policy constraints are met. So what the agent can pursue a goal by set of steps. First one is planning some sort of actions, next invoking different types of tools, and then observing outcomes, what is the outcome it can get. Next, updating what it knows, and then repeating this loop until the object can reach. An AI operator can decompose a task, call the right services at the right time, check its own work, and either finish or ask for help, for example, human approval. Then only the agent has to complete its task. Here it is the basic agent architecture. Here it is the environment, and from environment it collects the data, and then it can transfer to the presentation layer. Here we have the monitor. This monitor will be monitored all over the perceptions in the layer or in environment what is going on. And then the AI model can analyze the problem, whatever the problem is going on, and then it can plan some sort of solutions and the choose the best solution, and the best solution will be accomplished by the executing the workflow. Here it is done by the execution layer, and some set of actions will be done in the environment. This is a basic agent architecture. Then here, what are the different types of agent architectures? The agent architecture is a framework which defines how AI systems organize different components to make decisions and interact with their environment. Here the main components are, it incorporates different types of sensors, processors and actuators in a cohesive system. So, how the evaluation is done from rule-based systems in the 1950s to today's sophisticated neural network-based architectures. Next, the two types of agent architectures are here, reactive and deliberative AI agents. It can represent two types of paradigms in autonomous agent design. Each have its own distinct characteristics. Next, about the reactive AI agent. This is the type of autonomous agent characterized by their simple and direct response to environmental stimuli. It can have predefined set of rules or behaviors that dedicate or that dictate their responses to specific conditions or inputs. Here, the environment has entered some set of inputs to the sensors. It can be observed by the reactive agent, and the set of actions will be performed by according to the rules applied, and then the action mechanism will be implemented to the environment. Here the main components of reactive agents are, first one is perception module, and second one is action selection module, and third one is execution module. These are the mainly three components in reactive agents. The reactive agent completely worked on predefined set of rules or behaviors that will be dictated by the user previously. Here, the components of the reactive AI agent. First one is perception module. Function. The perception module acts as the agent's eyes and ears and gathering some sensory data from the environment. Here, what are the different components? These are treated as sensors, devices or some software mechanisms that detect and measure various environmental parameters. Here the data will be processed. The initial processing and filtering of sensory inputs to make the data usable for decision making. Whatever the data collected from the sensors will be pre-processed or processed initially, or filtering. These types of tasks are done in data processing. And then role. This module collects processes data from the environment and provides the necessary information for the agent to understand the current state. These are the main heart of the agent system. Perception module is the main component in reactive agent. Next, action selection module. Here the function is worked as brain of the operation. Here the main components are rule based systems. It is the collection of if then rule based that maps specific sensory inputs to actions. Here the behavior table will be drawn. The list of possible actions are based on different sensory inputs will be filled. And the role here, the module processes the data from the perception module. It matches it against the predefined rules and selects the best action to perform. Next, third one is execution module. According to the plan, action plan defined in the previous component, it translates the selected action into the real world. Here the components are actuators. In this, the physically carried out these actions such as motors in robots. Command line interfaces are worked to execute these certain selected action on different APIs calls or system functions. Here, the main role is to implement the decisions made by the action selection module. Next, what are the different examples of reactive AI agents are here? First one is robotics. Reactive agents are widely used in robotics, especially for tasks like navigation and obstacle avoidance. For instance, a robot might use a reactive control system to avoid the collisions by changing direction when it detects an hurdle. Next, simulated creatures. In many types of games, we observed the different types of animals and different types of users are there. To control the behavior of these characteristics of the animals or humans, it reacts the player's actions and environmental changes. This is the example of simple reactive agent. Here, the agents are working together with the environment. Here, the condition is whether the temperature is less than 20 degrees, it turns heater on. Else, if the temperature is greater than 20 degrees, it turns heater off. It will be done by the actuator and the output will be carried out to the room or the environment. Okay, this is the simple reactive agent example. From this environment, it gets the particular temperature to the sensor. After that, it can analyze the data. Condition based rules applied here. If the temperature is below 20 degrees centigrade, automatically the agent can on the heater. Or else, if the temperature is greater than 20 degrees centigrade, it off the heater. It can be done by the actuator. Okay, it can be carried forward to the environmental change. Next, second type of architecture here is deliberative AI agent. Deliberative agents belongs to a class of AI agents that maintain internal models of the world. There, in reactive AI agents, there is no past history. There is no maintenance of the records of the tasks or input sensor data. Whereas in deliberative AI agent, it can track the changes whether if the environment can made. So here that maintain the internal models also. The AI agents can plan and execute tasks based on specific goals. It analyzes its environment, assess possible actions and choose the best course of action to achieve desired outcomes. For example, autonomous vehicle that navigates routes using real-time traffic data. Unlike reactive agents, which it responds instantaneously, whatever the changes done in environment. Deliberate agents make decisions strategically based on long-term goals. Here, their behavior is guided by some of the reasoning, planning, and evaluation of outcomes rather than direct stimulus responses. This is the deliberative AI agent. Here, in this step, first of all, the sensors get input data from the environment. After that, processing is done, and after that, controlling is done. This control will be going to the or carry forward to the environment. In between this, in processing, there are three steps are there: initial state, evaluation, and then prediction. The agent can have certain goals. Next, what are the different components and their explanation in deliberative AI agent? Internal state. The internal state represents the current state of the agent, including its beliefs, knowledge, goals, whatever its intentions. and any other relevant information related to the environment. This will be treated as the internal state of the agent. And then evaluation. Evaluation refers to the changes or updates that occur in agent's internal state over time. So this evaluation will be changed according to the input carried out by the sensors. Based on new information received from the sensors or changes in the environment, it will getting into the evaluation. Next, third one is prediction. Third component is prediction. It can predict agent's ability to anticipate future states of the environment based on its current state and past experiences. Next, fourth one is sensors. Sensors are the input devices or channels like cameras, microphones, temperature sensors, and etc. Through these these sensors, the agent can perceive information from its environment. These could include certain number of tasks. Processing. Processing refers to the cognitive processes through which the agent can analyze, interpret, and synthesize information received from the sensors. Means here the some processing is some sort of set of actions are planned to process. And then goal. The goal represents the objective or desired state that the agent can aims to achieve. Goals provided direction and purpose to the agent's action, guiding to its decision making process. And then control mechanisms enables the agents to regulate its behavior and actions in response to changes its environment or deviations from its goal. Suppose the controlling is compulsory in autonomous vehicle driving. In road, on road, different types of vehicles and different people or pedestrians are there. Several signals are there. According to that levels, it can controls the car. The agent can controls the car in different situations. Whatever it senses from the image processing and computer vision techniques through some type of sensors, cameras, radars, likewise. Next, environment. The environment encompasses external surroundings or context in which the agent operates in and interacts. It includes physical elements, other agents or entities, and any other factors that influence the agent's behavior in decision making. So, this is the main difference of reactive and deliberative agents. In reactive, the current state will be followed by the sensors and processing will be done. Whereas in here, the long-term goals are achieved and to by taking the decision autonomously by the agents. Here, we have the third type of architecture here, hybrid AI agent. Here in this, it combines the various good levels from or good characteristics from different types of agents. Here it integrates symbolic AI and machine learning concepts. Symbolic AI means rule-based systems manages these rule-based systems completely manages the structured and decision-making tasks. And then machine learning, it is completely based on data-driven methods. These components deal with the uncertain or dynamic situations through adoption. There is no certainty and in some environments. In that situations, machine learning can train the model and completely it can depend on the data driven methods. This combination balances improving the agent's versatility and performance. These agents integrate features like simple reflex agents, model based reflex agents, and utility based agents. These three combinations will be completely accomplished in this hybrid AI agent. These are the different components in hybrid AI agent. First one is perception module, second knowledge base, third one is learning engine, fourth one is reasoning engine, fifth one cognitive computing agents, and last one interactive layer. When coming to the perception module, gathering information from sensors, users, inputs or other systems to the agent knows what is happening in the current situation in the environment. It is called as a perception module. It will be collected from the environment. And then knowledge base. In this component, some sort of rules are stored, facts and structured information that the agent can refer to making decisions. It is given by the human. And next, learning engine. With the help of machine learning, agents can detect the patterns, learns from the new data, and improves predictions over time. Next, fourth one is reasoning engine. By applying some sort of logical rules, hybrid reasoning AI agents make clear and consistent decisions based on the knowledge base. According to the reason, this reason only, the agent can get some sort of tasks to accomplish the task or to reach the goal. Cognitive computing agents. This enhances reasoning by understanding context, solving problems, and making decision like a human. And then last one is interactive layer. It allows the agents to communicate with the users, with other users, with other agents, or to communicate with the human machines or other agents, making it practical in real world environment. To reach the goal in multiple agent system, the agents will be communicated along with the resources, whatever it may be sharing. Next, the key stages in action cycle of agents. We already discussed about the perceive or observation from the environment. It will be carry forward to the reasoning or thinking, and here the large language models are worked to think according to that reason, and then reflect, feedback, learn. Here some processing are happens, some processing steps are happen by using some APIs, and then act, feedback, learning. The outcome will be treated as the treated as the experience to the agent to improve its performance to the next level. Here, one example of a hybrid perception. Here we consider about the health monitoring agent. Here the perception is real-time vital signs. Here we consider three types of levels: HR, health record, blood pressure, and glucose levels. It can be treated as input measures in the condition of in the state of patient. Next, reactive, immediate alerts if critical thresholds breached. The agent can have some certain levels of thresholds to the above perceptions. If the levels of a patient will be recorded as increased levels or greater than these thresholds, the agent can react. Next, deliberative. It can analyze the patient records or recommended some type of interventions deliberately in long-term goal. It can process some set of tasks. Learning. ML models predict the patient weakening patterns, how the patient has, what type of diseases it has, what type of levels will be increased in future. This type of learning will be done by the machine learning in this agent. Thank you.